This is the scoping workshop, the computer science workshop, week number 2. My name is Noah Houchins, and this is going to be a shorter workshop, but this is an important topic that can be very confusing. So I wanted to allow a lot more time for questions, and I didn't want to combine this with a different workshop because I wanted to keep everything sort of on topic. So when we talk about scoping or the scope of variables, what do we mean? Scope refers to the space in your code where a variable exists and can be referenced. So I'm sure all of you have experienced if you're trying to use a variable that has not been declared yet, it doesn't work. For example, I have this int variable called b that I've declared right here. And if I go before this line and try to print out the value of b, I get an error. And this error says b cannot be resolved to a variable. And then it gives me a couple options of ways I can fix that. But we already have this b variable created here. So we need to reference b after it's declared. So if I were to change that line and move it down there and print out the value of b, now this works. Everything is running smoothly. There's no errors. So when we talk about scope, we're referring to where can we reference b? If it's declared here, we can't reference it up here. It doesn't exist yet. But the existence of b can also end. So I can reference b here, no problem. I can reference it inside this if statement. I can reference it after this if statement, and everything is fine. But if I were to go down here into this other method, and if you don't know what a method is, that's okay. You'll learn soon enough. You don't have to know what a method is to understand what we're going to talk about today. If I try calling sysout b here, suddenly we get an error again, even though this line is after this one up here. Well, the problem is we're in a different scope. So when you think of scope, there's two things that I want you to keep in mind. The scope is always relative to these curly brackets. This is how you can very quickly and easily identify your scope. If I make a variable called c inside these curly brackets, then that variable c only exists inside those curly brackets. For example, we have this int c equals 3 variable, but if I go outside of this if statement and I do sysout c, it doesn't work. C no longer exists. It only exists inside here. So a common phrase, this is the second thing that I want you to keep in mind. A common phrase that I like to use is what happens in Vegas stays in Vegas. When you declare a variable inside these curly brackets, it has to stay there. You can only reference it inside those curly brackets. There are some languages where this doesn't exactly apply, like JavaScript or Python, because you can create a global variable anywhere and then reference it afterward. But in Java, you cannot do that. Once you declare a variable, its scope is where it is, and that's always what its scope will be. You can't change it after the fact. Now, there are 3 different levels or types of scope, and I have them all laid out here. The first one is class level. And this just means any variable that's created just inside of the class itself. So there's no method surrounding it. We have the public class scoping, and then the variable is just right after that. The curly brackets that are containing it are the ones for the class. This you can think of as a global variable per se, but it's a little fishier than that, a little more complicated. But for now, you don't have to worry about that. That'll come when you talk about classes and objects, which is another workshop that's coming up in a couple weeks. For now, all you have to know is that if you make a class level variable, such as this, and here we've defined it as static. Again, you don't have to know what that means, but that's okay. As long as we've declared it out here, I can reference it anywhere else, essentially. So in here, I can say if a is greater than b, and it's referencing this variable out here, you can see that it's blue because it's recognizing that it is class level, and it's highlighting it so that we know it is referencing that same variable. I can reference it down here in this other method because this method is inside of our class. This method is inside of our class, So that variable is in the correct scope. So anywhere inside our class, we can now reference that variable called A. Then we have the next level of scope, and this is called the method level scope. So this is any variable that's created inside of a method. In this case, we have our main method, which is the method that runs whenever we have any Java program and we run it. This is what it looks for. If I create this, as I mentioned before, I created this B variable, and this B variable only exists inside this method between these two curly brackets. This would also be a method level scope, since D is being declared inside a different method, but it is still a method. So D doesn't exist up here, and B does not exist down there. They're in their own scopes that are separate. Lastly, we have something called block level scope, which refers to whenever we have a structure or curly brackets inside of a method. In this example, we have an if statement. And the way that we wrote this if statement, it has the curly brackets. So C, this variable that we've made here, has block level scope. It only exists inside this block of code, which is why it's called block level. The same goes for loops. If I make a variable int e and then try to reference it outside, it doesn't work because e only exists in this for loop. We have these curly brackets. That's our key. For loops, while loops, just anytime we have those curly brackets, we're creating block level scope. And in fact, we don't even need a structure to begin with. I can delete these and just put curly brackets. And now I've created a sort of structure where it'll still run like normal code, but if I try to make a variable inside, I've given that variable block level scope instead of method level scope. So you can see if I delete these curly brackets, suddenly E now exists in the rest of this method down here. But if I add those curly brackets back in, now it doesn't exist here anymore because we've created a block level scope and we've declared the variable inside of it. So that's where it exists. So this can be helpful if maybe we want to just do something specific and we only need a variable for a short period of time. We can create a block here, do whatever we need to do, and then once the block ends, those variables that we created disappear. And that lets you use those variable names again. So I can say int e equals 6 inside the block. After the block ends, I can say int e equals 7. Our error goes away. And if I run this code, it prints out 7 because it's referencing this e variable, not this one. Now I want to switch over to a different program, and it might look a little bit intimidating. That's okay. Again, you don't have to understand exactly everything that we're doing. I just want to point out some things. So this is a simple program that finds the sum of a list of numbers. So in this case, 1, 2, 3, 4, 5 should give us 15. However, we have an error right now, and that its sum cannot be resolved to a variable. So if we look for the declaration of sum, we find it inside this for loop. And as we mentioned before, there's curly brackets here, which means this sum variable is being declared in block level scope, whereas we're trying to reference it afterward in method level scope. We're moving up a scope, and we can't do that. We can only move down a scope. So I reference nums, or I declare nums in method level, but I can reference it in this block level. So we can always go down. We can't go back up. That's another important idea of scoping. So not only does this not work because sum doesn't exist afterward, but also what's happening is that every time this loop restarts, this is just a simple for loop that goes through each number. So this loops 5 times because we have 5 numbers here. Every time it restarts, sum gets reset back to 0, which isn't very helpful if we're trying to add together all these numbers. So we can move this declaration outside of this block, and that will solve both our problems at once. If we move it here, now suddenly this error went away because sum exists in this method level scope, and it doesn't get reset every time the loop restarts. So we have sum equal to 0. Then for every number in our list, we add that number to sum. Now when we print out sum, we get 15. So that's the sum of all the values in our list. So I wanted to specifically use this example because this specific problem comes up a lot, especially in early programming. And I see this mistake made almost every time, that they declare a sum variable inside the loop itself. So I thought this would be helpful to see and explain what's going wrong and why. I think that's about everything when it comes to scope. So again, I mentioned this was going to be a shorter workshop. So I wanted to open the floor now to some questions, or if there's anything maybe on one of the handouts that I didn't cover. So please feel free to ask, or if there's other examples you would like to cover as well. So I'll let some time for people to type if they have a longer question. In the meantime, I did think of one other thing I wanted to mention. Please feel free to continue typing any questions that you may have. Back to this program from before, let me get rid of some of the parts that we don't need. We created this class variable up here, and then we referenced it afterward in our method level scopes, right? Which was, again, moving down. We went from class level, which is the highest level scope, we went down to method level. So we're allowed to do that. I also wanted to point out that specifically when creating class level variables, this is the only, or one of the only times where you can declare a variable. So I'm going to call this one E now. Declare a variable after the point that it's referenced. So if I declare E on this line 21, I can then go inside this main method here and reference E, and I don't get an error, and this will print out 6. So even though E is being declared after the main method, it still exists in the main method. And the reason for that is because we're dealing with static variables. So when you compile Java code, the first thing it does is it looks at all of the code in this class. So it says, okay, we're creating a static int variable called A. We're setting it equal to 1, and the scope is at the class level. Then it moves on and says, okay, here's the main method. That's good to know. Here's everything inside of it. But we're not going to run it yet. First, we're going to just keep going and scanning through our code, this whole class. Then it goes down here and says, okay, here's another variable called E, which is also an int. This one's set equal to 6. And this also has a class level scope. So actually, let me type that out as well. Then it moves on and says, okay, here's another method called other method. And this has an int in it and does some other stuff. Great. And then it goes back and it runs the main method. So because we already scanned through this whole class and read this variable, now it exists. So it's out in our class. There's no specific order to when methods or methods and class level variables are referenced. As long as they exist in the class, they can be referenced in the methods. Any questions about that or anything that we've covered? Does that apply only to static ints? No, we can do this with any static variable. In fact, it's any variable, but I put an asterisk on that because I don't want to get too deep into talking about classes and objects for fear of confusing people. I mean, I could talk about it a little bit. So I guess a disclaimer, if any of the next part that we're going to talk about confuses you, don't worry about it. Just ignore it, and then you can revisit it later once you've covered classes and objects. So with that out of the way, I can do a static variable. It doesn't have to be an int. If you're specifically if you're asking about ints, I can say static string s equals hello. And then I can print out s inside this print line here. And then it prints out hello. And again, I can also move that afterward, and we get the same thing. So it's not specific to ints, but if you're more referring to the fact that it's static, if I were to create a constructor, if you're familiar with objects, hopefully you know what a constructor is. If you don't, again, don't worry about it. You can ignore any part that confuses you. If I create this constructor here, and then I create a class level variable that's not static, we'll call this one f. We'll give it the default value of 5. I can reference that inside here. So I can change the value of f or print it out. So it does work the same way in the sense that you can declare a variable inside the class anywhere in the class, and it is available to any method. But since this variable is not static, we cannot use it in a non-static method. So if I tried to print out f here, it wouldn't work. And here it says we cannot make a static reference to the non-static field f. So I hope that kind of cleared some stuff up. We can reference static values in non-static methods. So this method here, which is not static, I can print out a, which is completely fine. So we can go from static to non-static. We can bring in static variables into non-static scopes, I guess, if you want to think of it that way. But we can't bring non-static values or variables into a static scope without instantiating an object. So hopefully that's the last of, we'll be talking about classes and objects and instantiation and all that. So if you're all confused, just ignore the past like 3 minutes of what I just said. Okay, next question. What if there's a variable, suppose a both at class level as well as method level? Okay, that's a good question. Not static. So we have this int f here, and then I can say int f equals 6. So yes, we can do this. The way that we reference, and you'll also see this come up, this does happen a lot more frequently than you would expect when we're creating classes and objects. You can see that this f is yellow and this f is blue, and these are indeed two different variables. So if I were to call system.out.println and pass in this f here, you can see that this one is yellow, so you can probably make a guess what number is going to print out when we call this. But if we wanted to access this blue f, the way that we would do that is using the this keyword. So instead of just saying f, we could say this dot f. And now you can see this f is blue. So that references, when we say this, we're referring to the class. So public class scoping. And now it's going to look for a class level scope variable called f. If it doesn't exist, this .f doesn't work. If we bring that back, if we get rid of this f, this one that has the method level scope, if we get rid of that one, now both of these refer to the same f. In this case, calling this .f is redundant. Did that answer your question? Again, sorry to anyone who's not familiar with classes and objects, but if you are, hopefully that all made sense. Okay, so what is the difference between f in the class and f in the constructor? They're not necessarily the same. So we declared this variable in the class, which means it has class level scope. So it exists in any object because it's not static in this case. It exists in any object that is made from this class. So if I go down into this main method and I create a new scoping object like that, and I say scope.f, and actually let me call sysout scope.f, you can see again that this one's blue. So it's referencing this f variable here. And now we don't have to say this .f. If we bring this back, right, we have this yellow f, which is referencing that f variable there, and then this .f, which is referencing this variable here. And let me bring this up to help reduce a little bit of confusion. So we can differentiate between these two variables because they are different. This method level variable only exists inside this method, whereas this class level variable exists in the entire class, or more specifically, it exists in the object created from the class. So if I call scope.f down here, I'm only referring to this one because this int variable called f no longer exists. So calling new scoping, when we create the object from this class, we're calling that constructor, which is this method here. So f gets created, and then we print out its value. We print out the value of this f, and then once this method ends, this f disappears. So they're not the same value because you can always overwrite. Well, okay, let me rephrase that. You can overwrite class level scoped variables. A block level scope variable cannot overwrite a method level variable. But when we define a constructor, the variables in constructors also have a scope of the object. Since this constructor is called when a new object is created. The variables that exist in the constructor don't have a class level scope. So I think what you're asking is if we said like int f here, like that. Is that what you're saying? So if we wanted to create a new scoping object, we'd have to pass in, let's see, 6, for example. Is this more what you're referring to? No. Okay, so what are you referring to? I guess I'm a little lost on this. Oh, wait, you know what? I think I know what you're saying. So you're saying if I have an int variable called f here, and I'll set this one to 10, you're saying if I go, okay, I don't understand the difference between the class level variable and the same variable in the constructor. Yeah, this is where it gets a little confusing. To everyone in the chat and everyone who's watching this after the workshop, if you've been confused by the past however long we've been talking about the classes and objects, again, don't feel bad. Don't worry about that. You'll get to classes and objects, and this will all make more sense. So you can just ignore anything that's confusing you. That's totally fine. This variable here, it defines the object itself. So let me see if I can sort of illustrate this, and maybe that will be better. So we have the scoping class, and I'll give a brief lesson on classes and objects. So hopefully people can follow along. This is our scoping class. This is everything that we have. Oops, right here. That's all of this code. Everything from the top to the bottom. We can think of this as a factory. So the scoping class is primarily used for creating scoping objects. So the scoping class creates a scoping object, and that scoping object can perform specific functions and tasks. And this factory can create as many scoping objects as we want it to. So it can have a scoping object here, it can have another one down here, and this would be a separate scoping object, but still a scoping object nonetheless. So these are both scoping objects. They do the same thing, but they are different. And we can also change the values inside them, and they're separate. So think of this as like a car factory. The factory makes cars. It makes as many cars as we ask it to. But every car is a different object. It's a separate car. We can say, I want a red Ferrari. Someone else can say, I want a white Ferrari. So the objects can differ, or they can be identical. Two people both ask for a red Ferrari. It's the same exact model, same parts, but the Ferraris are still different. So inside the scoping object, there is a value called f. And f is equal to 5. So f is also equal to 5 here. So these are the variables that are created in the object themselves. So this f doesn't exist in the main method, right? Because as we mentioned earlier, this variable isn't static, so it can't be referenced in a static scope. We can only make static variables inside here, or reference static variables like a inside here. When we create the constructor, and when we create the scoping object, this is the code that does that. This is the factory, the part of the factory that makes the objects. So when we make a new scoping object by calling new scoping, it's calling this code here. In this case, we're passing in a 6, and then it's being stored in this int variable here. And actually, this might be even a little too confusing. Let's go back to what we had before. So I'll say int f equals 6. So now we have these two different variables that we have. We have int f equals 5, which is being stored in the object. Then int f equals 6, which is being stored in, it's technically being stored in the object, but only in this method. So there are two different variables that have the same name that represent two separate things. So similar to how we have two different objects that sort of represent the same idea, two Ferraris are both Ferraris, they're the same, but they're two different objects. So this variable and this variable, they have the same name, but they're two different variables. So we can take f here, this one that's created in the constructor, right, which has method level scope, and we can do whatever we want with it. And that does not affect this f variable out here, which has class level scope, because they're two different variables. As soon as I say this dot f, now we're referencing this variable here, which is the class level variable. So this is just an easy way to say the object that we're in. So when we're in this scoping object here, and we say this, we're really just making an arrow pointing to itself. The scoping object is this. So we want the f variable that's in this scoping object, which is this one, it's 5, the one that's being stored up here. If we don't say this, we're always going to use the most recent or the lowest level of scope. So because class level scope is the highest, then method level scope is one step below that. That's this variable here that has method level scope. That's the one we're going to reference if we just call it by its name, if we just say f. But if we say this dot f, we can circumvent that and specifically say, no, I want to talk about the class level scope, not the method level scope. I know it's a little confusing. Again, I hope none of you take this as I'm going to give up, I'm going to stop learning programming, because you really shouldn't. Like, keep working at it. I understand how confusing this is. Again, if you just need to ignore everything I just said, that's totally fine. I get it. I understand. I encourage all of you to come back and watch my Classes and Objects workshop in a couple weeks. In fact, I encourage you to come back to all my workshops. I hope I see all of you again, because I enjoy making these. I enjoy helping you, and I like getting the questions and having this interaction. So now let's get rid of all this object talk. Don't need any of this. I don't want to keep confusing people more. Okay, so now I think we're back to what we had. All right. Are there any other questions? We've got 18 minutes left, but we don't have to use the full 18 minutes. That's okay. Alternatively, if you have more questions about this whole idea of classes and objects, feel free to stick around after the workshop and we can talk more about that. I have no problem if you are free and available to do that. Another question: what are some examples when scoping variables could be useful, like overloading variables? Okay, so in this case, if we have a static variable A and we create another variable at a different scope with the same name. So I guess this you could consider overloading a variable, since we're making two variables that have the same name. When is this useful? It's very useful in classes and objects. Again, sorry to bring it back to that. It's very useful in that. It's useful if, ideally, you should avoid doing this, I suppose, because it can be confusing for the fact that we just talked about it for the past 20 or 30 minutes or so. It can be confusing, so I advise you to not do this. But if there really is, like, this is the perfect variable name, I have to name it this, which just so happens to also be the name of this variable up here, like there's nothing else I can name it, then yes, you can do this. That's fine. In this case, if you wanted to reference this variable A, I don't think this would work. So this dot, yeah, this dot A doesn't work. but maybe if you said scoping.a. Hold on, let me print it out. Yeah, so similar to what we did before, instead of saying this.a, you would just type the name of the class. So scoping.a will give you this a variable. So you still have access to both in this sense. Again, I would just avoid using this altogether. I don't necessarily know if there are examples when doing this would be helpful, but I suppose it does happen and sometimes it is unavoidable. That's a good question. Any other questions? Okay, looks like everyone is satisfied. No other questions. I'll just give it another couple seconds or so. But other than that, I guess that would conclude the scoping workshop. Okay, looks like there are no more questions. So thank you for those who attended. I'd ask please stick around for just another second or two so we can clarify some things. And to those who are watching, thank you for watching. Sorry you couldn't make it, or if you're rewatching, thank you again for coming. And hopefully I see you in a future workshop.